Let's look at some example capacitors. I mentioned a variable capacitor before, a parallel plate variable capacitor before, that's used for tuning radios in the past, and then probably TVs as well. In the graphic here, what you are seeing is an illustration of how that works. Okay, let me show the working version. Now, normally this would be connected to the knob. And as you act on the knob, this is what you are doing. You are changing the overlap between the plates. So when you decrease the overlap, like here, let's see, like this part here is not overlapping with the corresponding part there, so we have a small capacitance. When we increase the overlap, we increase the capacitance. In the big picture, the capacitor is going to work as well as a tuner. A variable capacitor is going to act as a tuner that's going to set up the frequency with which the radio or the TV or the cell phone signal is being sent. So part of any transmitter of radio or phone or TV signal is going to have capacitors that are used to tune the signal to a particular frequency. That's probably one of the biggest uses of capacitors. Another use is the condenser microphone. Within the condenser microphone, there are two plates, one connected to an electrical lead and the other one connected to another lead. And as you talk, those plates are made up of material that can easily be affected by the pressure due to the voice. Now, the pressure due to the voice is going to put these plates closer to each other or further apart. By putting them closer to each other or further apart, the capacitance of this particular parallel plate capacitor is going to change. And as it changes, that would affect the current in the electrical circuit. The change in electrical current is going to correspond to the sound being produced. And that current, like we talked a few minutes ago, is going to be transmitted through the air or wires to other places, and it will be converted the opposite way, using instead of a microphone a speaker so we can hear it. Another interesting use for capacitors is what we call the stud finder. In this particular case, the two conducting surfaces in the stud finder are actually within the device. But the stud, the material between those plates, among them the stud, the wall, are going to act as the dielectric between the plates. So as you move this, depending on what's behind the wall, the dielectric constant is going to change. And as the dielectric constant is going to change, it's going to change the capacitance, and that's what's detected, and that's what allows us to figure out if there is a stud or not. Now, another parallel plate capacitor is formed whenever we have a storm. What happens whenever we have a storm, negative electrical charges are going to accumulate at the bottom of the clouds. These negative charges are going to are going to repel the negative charges at the surface of the Earth. So as they do that, that will make the surface of the Earth, just below the clouds, positively charged. So then we have a positive charge in one side, a negative charge in another side, and that's a huge capacitor.